All right, so in 3-4, we talked about a bunch of things related to perpendicular lines, right? If two lines are perpendicular to the same line, then they are parallel. If there are two parallel lines and one is perpendicular to line, then the other one is perpendicular to the line, like we talked about, a lot of stuff like that. So, and one of them added to the ways that we know that lines are parallel, right? So we now have 6 methods to proving lines are parallel. For number 1, it just says find the measure of angle 3. So what are we using here? Like what kind of angles and you're applying? What kind of angles? Mars?
Basically, 72 and the angle that's vertical to 3 are complementary.
Okay. So you went to the left, like you went across this way and said that this would be 3? Or did you go the other way?
Yeah.
And said this would be 72?
No, I went that would be 3.
That this angle would be 3.
Yeah.
And these would have to be, they would have to be complementary or add up to 90 degrees because the angle on the right is 90 degrees. These 3 form a line, right? So those, I mean, there's a lot of different ways to look at it, but that's one way. So then I would do what with that 72 to get angle 3?
90 minus 72.
Good.
Which equals 18.
Good.
And what else equals 18 this angle?
Right, so this is 18 and this is 18. Good. 2 says, how do you know that A and B are parallel?
Because they're both perpendicular to line C.
Okay, which it has that, like I was just talking to Mr. Yurko about it. It has like the longest name. Like that theorem has the longest name that makes no sense to me. So like I tend to just write it out because they are both perpendicular to the same line. Okay, so both A and B
So what theorem would we write?
are perpendicular. It's the perpendicular line transversal theorem. Yeah. They are both perpendicular to line C.
So
Okay.
we can just write that on the test.
Yes,
Can we
right?
do that
Because it's
for-
perpendicular.
Can we do that for every single one?
No, you're not writing. No. If this is like a reason in a proof, you have to write out if two coplanar, because they have to be coplanar, lines are perpendicular to the same line.
Is this transverse?
Yep.
Perpendicular transverse.
Then they are parallel, which is perpendicular line transversal theorem. So like on big ideas, and when you're dragging and dropping, obviously you need to know the name, but if you're using it as a proof, you literally could just write it out.
Perpendicular.
All right, 3 says find the distance from point E to FH. So E is here and FH is this line here. Which segment do I use to show the distance between these? GE, right? The perpendicular segment. So I need to find the distance between G and E. G is 1, 2. E is -4, -3. Distance is square root of x2 minus x1 squared plus y2 minus y1 squared. So it doesn't matter which ones you make the 1s and the 2s as long as you're consistent. I would get the square root of -4 minus 1 squared plus -3 minus 2 squared, square root of -5 squared plus -5 squared, square root of 25 plus 25, square root 50. And then on big ideas, it would have asked you to like round that to the nearest decimal place. But no, on your test, you're not going to have a calculator. So on the test, you're going to keep it exact, which means I now have to check this to see if I can simplify it. And this is 2 and 25, which is 5 and 5. The pair of 5s goes to the outside as a single 5. And this is 5 root 2. Questions? All right, so last lesson in chapter 3, which is going to be the last lesson that's on your test next Tuesday, is finding and using slopes of lines. So the good news is a lot of this is repeat. A lot of the stuff about slopes comes from Algebra 1, okay? But it's been a little bit since you've seen it, so maybe you need the refresher. Okay, first thing is just the definition of the slope of a line. So the slope of a non-vertical line is the ratio of the change in y, or the vertical change, to the change in x, or the horizontal change. The variable we use in equations for slope is a lowercase m. If I'm given 2 points, I would find the slope of a line that connects those points by doing y2 minus y1 over x2 minus x1. This is also known as rise over run.
Don't tell me we're gonna go back to slope.
We're going back to slope intercept form. So in this diagram, if I wanted to know the slope of the line that passes through these points, I'm going to count the rise over the run, or I can use the 2 points in the y2 minus y1 over x2 minus x1. And here it says non-vertical because verticals would have undefined slope. So that's what it's talking about, obviously, an undefined slope. You would not be able to find, you would be undefined. There are 4 types of slope: positive, negative, 0, and undefined. Positive slope rises as you move from left to right. Negative slope falls as you move from left to right. 0 is horizontal, and that's a special kind of equation. It's a y without an x. So there's no x in that equation. The other ones are like y equals mx plus b. And then undefined is a vertical line, and those have a special equation because there is no y. So if you thought about like a treadmill, if you've ever been on one and you increase the slope, or if you increase the incline, the higher it is, the steeper it is. If you had a negative incline, it'd be like walking down a hill. If it's flat, it sits at 0. And if you could somehow get it to go straight up and down, there would be nothing to grip on. There's no slope, which is the same thing as undefined. So undefined, you'll also see the word no slope. All right, slopes of parallel lines. Again, something you already know, but it is something that is proven, which means it can also be turned into a theorem. In a coordinate plane, 2 distinct non-vertical lines are parallel if and only if they have the same slope. So if I knew the slope of one line and then I told you that they were parallel, you would know the slope of the other one. They would be the same slope, okay? And vice versa, if I wanted to prove that they were parallel, I could show that they have the same slope. Slopes of perpendicular lines state that the product of their slopes is -1, which means that, and I use this more commonly, they are opposite reciprocals of each other. Opposite meaning if one is positive, the other is negative. And reciprocal meaning we flip it, okay? If my initial slope is 1/2, then the slope of a line perpendicular to it is -2. We change the sign and we flip it. And horizontal lines are always going to be perpendicular to vertical lines because, again, they would meet at the right angle, but because those like if 0's in the top, which gives you the 0, and you flip it, it now goes to the bottom, which makes it undefined. So horizontal and vertical are always perpendicular. All right, so complete with always, sometimes, always, or never. The slope of a vertical line is blank 0. Never. The slope of a horizontal line is blank 0. Always. The slope of a line that rises to the right is blank positive. Always. And the slope of a line that falls to the right is blank negative. Always. Easy stuff, right? You just got to remember vertical, undefined, horizontal, 0. So like the word horizontal has the O's in it if you think of zeros, okay? Or it just makes sense, yes, but some people tend to have a problem remembering it.
Vertical is E, and there's E in there.
Okay, but that only works if it said 0. What if it said vertical line is blank, undefined? Now it's always, right? All right, example 2, find the slope of a line through the points named. So I'm just finding slope here, which means m equals y2 minus y1 over x2 minus x1. And again, it doesn't matter which ones you make, the 1s or the 2s, as long as you're consistent. So a, x1, y1, x2.
Wait, y2 minus y1?
It's y2 minus y1, yeah. 5 minus 4 over negative 4 minus a negative 3 becomes plus 3. And I get 1 over negative 1, which is negative 1. And go to B. Negative 2 minus a negative 3 becomes plus 3 over negative 1 minus 6. And I get 1 over negative 7, or negative 1/7. Yep.
For the first one, when you did 5 minus 4, wouldn't it be 5 minus negative 4? And then,
No, it's 5 minus 4. And then it's negative 4 minus the negative 3. Yeah, you're welcome. All right, C would be negative 4 minus a negative 4, which becomes plus 4, over negative 3 minus 8. And I get 0 in my numerator. 0 divided by anything is what? 0. What kind of line would pass through those points? Horizontal line. Good. Yep.
0 is in the denominator, it's undefined.
Correct. Good segue. Because 9 minus a negative 2 becomes plus 2. Negative 6 minus a negative 6 becomes plus 6. And I get 11 over 0. And that's undefined. Which means that that line would be
Vertical.
vertical. Good. Questions so far? All right, so this is just completing a table. So on the left, it's giving you the slope of line R. In the middle, it's the slope of line S. And on the right, it's the slope of line T. In the directions, which is obviously important, it says R is parallel to S. So what's the relationships between the slopes of R and the slopes of S? They're the same. So if I'm given negative 1/2 for R, then I also have negative 1/2 for S. And then it says R is perpendicular to T. What's the relationship between the slopes of R and T?
2.
What's the relationship?
The opposite?
Opposite and?
Reverse.
So close.
Like flip the
Reciprocal. Good.
Reciprocal.
So what would be the slope of T?
2.
2. So for B, it's giving you T. You got to work backwards. If T is 1/6, what's R?
Negative 6.
Negative 6. And then S?
it's 6.
Negative 6, because it's the same as R. C gives you S. So where can I go from there?
R.
R would be
1/5.
1/5. And then from there, T?
Negative 5.
-5. Same for D. S is -4. So then R is -4. And T is 1/4. E says T is A.
So would it be negative 1 over 8?
Good. Negative 1 over A is R and also S. And then F, 3B over 4 is the slope of T. So
Negative 4 would be B.
good. And these would both be the same. Still good? Questions? All right. If R is parallel to S and R is a horizontal line, what's the slope of S? 0, right? If they're parallel, that means that S is also horizontal and the slope of a line that is horizontal is 0.
0.
R is perpendicular to S, now it would have been undefined.
Are we gonna have a table like the exact figure of the text?
No. So if K is perpendicular to N and N has slope 0, what's the slope of K? Undefined. What kind of line would K be? Good.
Vertical.
Now we get into the equation of a line. So that was just the slope of the line. Now you get into the equation of a line. The most common form is slope-intercept form. So this is y equals mx plus b. I would say it's probably the thing people most remember, okay? You will also learn point slope, but for now we're talking about slope-intercept. The m of this equation represents your slope, and the b is the y-intercept. So if it just says find the slope and the y-intercept, then you can just pull out the m and the b if it's in slope-intercept form. If it's not, then you're going to solve it for y, and then you're going to figure it out. So I'm going to do b first, and then we'll go back to a, because b is already in slope-intercept form, right? This is in y equals mx plus b form. So my slope is what?
Negative 1/4.
-1/4. And the b is
2.
2. And then if I was to graph this, because it says to graph, I'm actually going to pull in a graph.
There's one under the page.
Oh, on your next. All right, so I'm going to graph B. I'm going to, like, example B. And the way you do that is on the y-intercept, you're going to locate your y-intercept, which is 2. So I'm going to go on the y-intercept to 2, and I'm going to plot a point. That's my first point. And then my slope is -1/4. So I can actually choose to keep the negative with the numerator or the denominator. It just can't go with both. As a habit, I keep it with the top. So this means I'm going to go down from my point 1 and then to the right 4. So I go down 1 and 1, 2, 3, 4 to the right. And I get my second point. Or I could have gone up 1 and to the left 4. It still would give me that same line. So depending on your spacing when you're given a graph, you might need to go the other direction. It doesn't matter. So you could have either gone down 1 and to the right 4 or up 1 and to the left 4. All right, so now go back to A. A is not in slope-intercept form, right?
You have to put it in slope-intercept form.
And how do I do that?
You put 2 to the other side.
So you're going to subtract the 2x,
And then you divide by negative.
negative 2x plus 6, and then I'm going to divide by -3. And I have to divide each term by it. So I get y equals -2/-3 is going to become +2/3 x, and then +6 minus 3 is -2. So what is the slope here?
Over 3.
2/3, and what's b?
Negative 2.
-2. So now I'm going to go to -2 on my graph. I'm going to go up 2 and to the right 3, and I can do it again, up 2 and to the right 3, just to get a nice straight line. You only need the 2 points. And that would be A. So this is B. And then C is y equals -3. There's no x here, right? Which tells me this is what kind of line?
Horizontal line.
This is a horizontal line, which means my slope is 0. And my b is
Negative 3.
-3. So I'd go to -3 and draw a horizontal line straight through it. If it was vertical, your slope would be what?
Undefined.
Undefined. And then there might actually not be a y-intercept if it's to the right or to the left of your y-axis. All right, now we're reversing it. Now they're giving you the information and it's asking you for the equation of the line. So it says to write the equation of a line passing through point -1, 1. That is parallel to the line with the equation y equals 2x minus 3. And I will tell you that there's 2 ways to do this. I'm going to show you both ways, but there are 2 ways to do this. And one is using points or the slope-intercept form of a line that we just used, y equals mx plus b. And I have to plug in for the m, and I have to plug in for the coordinate point, which would be the x and the y. So I have the point. This is my x and this is my y. What I don't have yet is the m. So what would be true about the slope of a line that is parallel to this line? It would have the same slope. So what's the slope of that line?
2x. Negative
2. 2 is the slope of that line. So the slope of a line parallel to it is what? 2. So I'm going to use,
Why is the slope not negative 3?
because -3 is the y-intercept. The
Oh,
thing,
yeah.
the thing attached to the x would be the slope.
Sorry.
He's not stupid. It's not nice.
That was
Not
a
nice.
stupid moment.
All right, so y is 1. M is 2. X is -1. And you don't know b. So I'm going to solve for b. Add the 2. B is 3. And now I have the m and I have the b, so I plug it back in. Y equals mx plus b. Questions on that one? So if you're good with that, you like that method, stick to it. I'm going to teach you something else, but it does you get to choose which one you want to use.
Can't you just flip the -3, make it positive?
No, it's total coincidence that the 3's are the same term or the same value. Yeah. All right, so the second method is actually using something called point slope. So the point slope form of line
What about using that?
is y minus y1 equals m times x minus x1. So for me, I actually prefer point slope if what you're given is the point and the slope, because you just have to plug it in once. You don't have to plug it in, solve for b, and plug it back in. So again, it is your choice what you do. But now that I know m, and so I know my slope and I know the point, I literally just get to plug that in as the x1, y1. So y stays as y minus 1 equals the m is 2, the x stays as your x, and the x1 would be a -1, so minus a -1. I get y minus 1 equals 2 times x plus 1, distribute the 2, and add the 1. So there's no plugging back in on point slope. Okay, on slope intercept, you have to remember to solve for b, and then you have to plug it back in. I would say they're both like on level, not that bad. But you want to use whatever you're comfortable with.
I mean, they basically take like the same amount of steps.
Yeah, you just don't plug it back in. So people sometimes get to the b and forget to plug it back in. That's all.
It's a skill issue.
Agreed. Questions on that? All right, example 7 says write the equation of a line J passing through the point that is perpendicular to line K with the equation 2x plus y equals 2. So I start with the point. I know my point, right? This 0.23 I'm going to use. But what's the slope of that line?
-2. Thanks.
Good. And how did you get there?
Because you get with the two.
The slope of that line, right? So perpendicular line K. So the slope of K would be, this would be rewritten as -2x plus 2. And the slope of this line is -2. The slope of a line perpendicular to that, however, would be what?
+1/2.
+1/2. So I'm using this slope and this point. You use nothing else from that second line. So I'm done with this line once I figure out its slope. Don't try to pull that b out. So now I'm going to use y equals mx plus b. The y is 3. The m is 1/2. The x is 2 plus b. 3 would equal, what's 1/2 of 2? 1.
Oh,
Wait, how does this slope 1/2?
Because the slope of the original line is -2, but we're talking about a line perpendicular. Yep. So now b is 2, and my equation is y equals 1/2 x plus 2.
Oh yeah.
I'm going to repeat it with point slope just so you see it again. Y minus y1 equals m times x minus x1. So y minus 3 equals 1/2 times x minus 2. Y minus 3 equals, distribute here, 1/2 x, distribute here, minus 1, add the 3. Same answer. So again, completely up to you what you choose. You can use both to check your answers if you want to. Questions on that one? Jonathan?
Wait, how do you find the perpendicular slope again?
You have to, so you're going to find the slope of the line that's given to you and then do opposite reciprocal. There's also a shortcut to finding slope if something's in standard form. So this equation is in standard form, which means the x and y are on the same side. And that equation is negative, or that shortcut is negative a over b. The a is what's in front of the x. The b is what's in front of the y. So it's just a shortcut to finding slope if you want to do it from standard form. If not, you just solve for y like we did. All right, last one. This one says find the distance from a point to a line. You don't have a graph on this, right? Yeah, no. Okay. So if I were to, I would actually, let me just give you a visual on it. If you could picture what this looks like. The point 1, 0 is here. Do a different color. Here. Okay. And the line y equals negative x plus 3. How would I graph that? I'd go up to 3.
Intersection, and then you'd go
Then the slope is
to the
negative.
right one down one.
Good.
It's 2.
How would I know what's the distance? How do I show distance from a point to a line?
This is 1.
Well, but how do I know which point to use?
You use the perpendicular.
I need to find a perpendicular one, right? So if the slope of the purple line is negative 1, what would be the slope of a line that's perpendicular to it? Positive 1. So if I go up 1 and to the right 1, this is going to be my perpendicular segment. And so I want to find the distance from this point to this point, which is 1, 0 to 2, 1.
Wait, if we don't have a graph, how do we do that?
You would have to graph. Yeah. I mean, you could like try to figure out the coordinate point in your head, 1 up and 1 over from the coordinate point. But if you were to do this on a test, you'd be given the graph.
Is it gonna be on this side?
I'm not going to answer that question.
Why?
Because you guys only listen to me if I tell you it's on the test. I'm not done. I'm done with these questions. Okay? All right, so if I want to find the distance between these, this would be x1, y1, x2, y2. I get d equals the square root of 2 minus 1 squared plus 1 minus 0 squared. Square root of 1 squared plus 1 squared. Square root of 1 plus 1. Square root of 2. So if this, and I don't remember actually, if a question like this is on your big ideas, it's going to ask you to round that to the nearest tenth. You would round it to 1.4. If it is on your test, then it would be kept exact. So it would be square root 2. Questions? All right, so that marks the end of not only 3-5, but what is on your test, okay? So your homework for the weekend is to do the big ideas for 3.5, okay? And if you would like to, like if I know that I'm going to be swamped on Monday because your test is Tuesday, like if I'm going to be swamped on Monday and I don't want to stress myself out, then I would also spend some time on your review this weekend. So the review, which covers like 3, 1, 2, and 3 were on your quiz. I feel like that content, you need to review it, but it's relatively easier, okay? 3, 4 was okay. 3, 5 has a lot of stuff in it. So you want to just make sure that you're focusing on both 3, 5 and also the whole review, okay? So the chapter review I published, you can start it this weekend if you'd like, okay? But it does go through all the content that's on your test. And then Monday, the goal is to come in with questions on what you need help with so that Tuesday you're ready to go.